Hey guys, welcome to day 3 of 812. Today's basically just another practice day, so whatever's in this video isn't necessarily going to be new, but it's pretty directed at our practice problems for today, so you're welcome. Okay, so let's go ahead and get started with this problem here. I've given you a polynomial in factored form as usual. Let's start by listing the roots, also known as the zeros. So remember, you get those from every set of parentheses, right? Everywhere there's an x, there's a zero or a root to be found. So this one, okay, this one you'll notice looks a little different than what we're used to. That just means that it's a zero of 0 or a root of 0. All right, this one, x minus 1, we know that we typically, if it's just like this and there's no number smashed in front of x, you could just take the opposite of it. So x minus 1 will yield a positive 1. X plus 3 will yield a negative 3, right? And what's really happening here is that if we were to set each of these factors equal to 0, like if I did x minus 1 equals 0 and I solved this for x, we would end up with x equals 1, and that's exactly why, we do this opposite action. It's just a shortcut. So, continuing here, x minus 4, that's going to give us a positive 4. So let's go ahead and list those out here. All right, so I have 4 roots, okay? Leading coefficient, here I actually do have a number in the very front of my equation, so that's going to be my leading coefficient. If I had any numbers squished in front of these x's, I would have to multiply those in as well, but in this case I don't, so all I'm focusing on is this 8. All right, the degree is how many x's I'm multiplying together in this case. So we have 1 here, we have 1 here, we actually have 2 right here because of this exponent of 2, and then we have 3 right over here. So we got 1, 1, 2, 3. If we add all of these together, we would end up with 7 of them. So we know that our degree is going to be 7 because when I do x times x times x times x times x times x times x, right? 3 of them, 2 of them, 1 of them, 1 of them. We would end up with 7. What would the end behavior be? Well, remember the table that we've talked about for end behavior, and if you don't remember and are too lazy to find it again, I will so kindly draw you one. So here is my mini end behavior table. Oh, that's a little janky. Oh no. Gotta redraw the whole thing. Gosh, I should just pause the recording for this, but you guys can just watch me struggle. Alright, so we have leading coefficient is either, positive or negative. And then on this side, I'm not gonna, well, maybe we could try. This is where we look at the degree. And what matters here is whether it is even or odd. Sorry, sometimes my handwriting on this tablet thing is just straight ugly. Sorry. Alright, so if it's positive leading coefficient and an even degree, we have up, up. Negative leading coefficient, even degree is just the flipped version, which is down, down. And then positive odd is down, up. Negative odd is the flipped version, which is up, down. Okay, so that being said, we have a positive leading coefficient because it's a positive 8. If it was a negative 8, then it would have been negative. The degree is 7, which is in fact an odd number. Okay, so we have odd, we have positive. That tells us that we are landing right here in this box. So down, up is our end behavior. All right, that being said, we can go ahead and start sketching our graph. All right, let's start by labeling all of these on our x-axis. So we got a 0 here. We'll put 4 over here. So 1 can be right here. And then negative 3 can be here. All right, it doesn't have to be like perfect, just, approximate. And then we can sketch our graph. The very most important thing to look at in the very beginning is the end behavior. If you know the end behavior is down, up, that tells you that your graph is going to be facing downwards on the left side right? So like right here. And the other side on the right, it's going to be facing upwards. So once you come out of that 4, it's going to be looking like this, right? So that's how you know where to start. Now it's very important now that you pay attention to what's happening at each of these. So at -3 comes from this x plus 3 factor. It is being squared, okay? That means that it is a double root. So we are going to have to bounce on a double root. On a triple root, we have to flatten, okay? On a single root, which is both of these, we go through. That's what happens when you don't have an exponent. It's like an automatic exponent of 1. So now that we've done that homework, we can go ahead and draw. So at -3, we said we were going to bounce. So that means we'll go up here, bounce off of -3. The next one at 0, we're just going to go through. So we'll just do some of this. At 1, we're also going to go through. So we'll do this. Ah, darn. That really bugs me. I'll work with it. All right, and then at 4, we're going to flatten. So it's going to look something like this. All right, and I'll meet my little arrows here. And this is my approximate graph. Now, as you guys know, I've said this before, we don't know like how low this really should be, these peaks, and we don't know how high this should be, but quite frankly, we don't really care either. This is a sketch, it's an approximation, so we kind of just need to make sure we can get right what we do know about it, right? And that's the x-intercepts and the end behavior. All right, number 2. If we wanted to graph this, what would the x-intercepts be? We really do already know how to answer this question. Like here, we found all our x-intercepts. They come from the roots, right? So when we take the opposite number of these parentheses, that's when we get our 0. And to turn it into an x-intercept, you just have to make it a coordinate point. So this tells us we have a 0 at 41, and this tells us we have one at 51. So sure enough, my x-intercepts will be 41, 0, and 51, it's ugly, 51, 0. All right, that's all there is to that part. Number 3, if a polynomial had the following x-intercepts, write a possible equation in factored form. So this is kind of like a backwards working version from this problem. Instead of asking for the x-intercepts, we want the equation. So you take all these numbers and you'll make an opposite kind of factor for it. So let's switch colors. I'm kind of bored of this one. So we can say f of x equals, and so this -2, 0 here means we have a root of -2. So that being said, it's going to turn into a factor of x plus 2, because remember, we got to use opposites. So x plus 2, this one is going to have a root of -1, which gives us a factor of x plus 1. So x plus 1. This -5 will give us a root of -5, which means a factor of x plus 5. And we have one more here. Let's go this color. This +5 will give us a root of +5, which gives us a factor of x minus 5. All right. This is a possible equation for it. Now, because we don't have any other information, it might not be, right? Because if we had like extra exponents or something, that's a possibility, and we just don't have enough information for that. So with whatever information they gave us, this is a valid, possible, potential equation that will go through all of these x-intercepts. So that's it for today. Make sure you give today's My Open Math problems a try, and let me know if you need help. Quiz tomorrow, if any of you guys actually watched this video today. All right, that's it.